Hi everyone, today I am going to explain about figure of merit of a galvanometer. About this experiment you already known very well in the theory classes. Now I am directly moving to circuit connection and how to take the readings. Here this is the battery, okay, having the two potentials positive and as well as negative. Here there are two terminals for positive 1.5 range and 3 voltage range. You may choose any one according to your wish. If you choose 3 volt you will get more potential. If you choose 1.5 volt you will get less potential. Okay, and this is the galvanometer used for measuring the deflection. Okay, here this is a 0, this side 30 divisions are there and this side 30 divisions are there. Okay, it is used to measure the deflection. Okay. Next, this is the resistance box. Okay, maximum range is 10,000. Here 10,000 range is there, means this is taken as a R, means higher resistance box, and this is the small resistance box known as S, means the resistance maximum range is less compared to R. Here this is having the 500 voltage, 500 ohm resistance. Okay, this is a S. Okay, here R and S are having the both functioning. Okay, here knobs are there. If you open any knob, okay, that much resistance will apply to the circuit. Now I am opening the 5000 knob. Okay, 5000 knob, 5000 ohm will be applied, resistance applied. Okay, in the same way. And these are the plug keys. We are taken the two plug keys, K1 and K2. Okay, K1 and K2. Here initially for a first half reading you have to open this key, you have to keep it open. K2 is open and you have to, this key is closed. Okay, for first half reading. Here after keeping this key closed, the needle is more than 30 degree. In galvanometer reading is showing more than 30 degree. Okay, here we have to choose the even number of deflection in the galvanometer by applying the suitable resistance in the resistance box. Here I will open the 10,000 key. Okay, 10,000. The light off. Okay. Here the needle is at 12th division. Is at 12th division. You have to measure the, once again. Again I taken another 500. The total is 10,500 resistance is applied to this circuit. For that I chosen 12th division, even number of deflection. Okay, here after setting even number of deflection you have to close this key. Okay, now both keys are closed. Now we have to set the half of the deflection. Half of the deflection means it has to show the 60. For that I am removing the 20, again 20 and 10. Now it is at around 6 division, means half of the deflection. Okay, in the same way we have to take the readings. Again we have to close these knobs for taking the second reading. You have to keep it open. You have to keep it open and we have to close these knobs. Again the galvanometer is at more than 30 degree out of range. Again we have to set the even number of deflection by unplugging the knobs in a higher resistance box. Here again for second reading, here I applied the 5 7000 ohm resistance. Okay. For 7000 ohm resistance I got 20 divisions. I got 20 divisions in a galvanometer, even number. Okay, this is first half. Okay, next second half is I am closing the plug key. Okay, then we have to okay. Now the galvanometer is at 10th number, means half of the deflection. Okay, 20 by 2, that becomes half. For making half deflection, here resistance applied is 20 plus 20. I applied the 50 ohm resistance to the this small resistance box. Okay. In the same way, you have to take one more reading. Okay. Like that, you have to obtain the readings. Okay. And all those things I will explain with readings. Here, this is the aim of the experiment, that is determination of the resistance of a galvanometer by half deflection method and to find its figure of merit. Okay, this is the aim of the experiment, and the principle is deflection of galvanometer is directly proportional to the current through the galvanometer. Okay, next, this is the procedure, and this is the circuit diagram. Here R means higher resistance box of range 10,000, K1 means plug key, G means galvanometer, S means small resistance box, K2 means another key. Okay, here for S means small resistance box, you may take the range of 500, 1000, 2000 or 5000 range. Anyone is applicable. Why? Because the small resistance box, the value is less within 100 ohm. We are unplugging the resistance. That's why you have to take the less value. That is enough. And next one is observation EMF of the battery. Okay, that is 2.5 volt. Okay, or you may take the shell value, whatever the you are having. And this is the tabular column. Okay, in tabular column, resistance are in ohm. Okay, and deflection theta in division. Here you have to set the even number of deflection in a galvanometer. Okay, first the my students are set at the 10. Okay, this is even number. For obtaining the 10 deflection, even number deflection, they unplugged the 17,000 resistance in a R. Okay, then after that we have to keep the another key K2 closed. Then the in small resistance box again have to remove the resistance, means unplug the resistance for getting the half of this deflection. Here 10 is there, half means 5. For getting 5 number of deflection in a galvanometer, we have to unplug the resistance in S. Okay, and after that take the another even number deflection, that is 16. For getting 16 divisions in galvanometer, they have to taken the 10,500 resistance. Okay, next after that again close the K2, then you have to unplug the resistance in S for getting half of this deflection. means 8. For observing the 8 division in a galvanometer, they have to remove the 50. Okay. Then in the same way, you have to take the another reading, and after that calculation is there. G equal to RS divided by R minus S. Here R is there, capital R, S is there, this is R, and this is S. R into S divided by R minus S. You have to do the calculation in separate part, and after that K value is there. E means EMF of the battery. Okay. Next, that is given value here. R is there, plus G already we found here. G value divided by, okay, R plus G into theta. Theta means this one, deflection. Okay. You have to do the simplification, and after that you have to take the mean values of this one. Which one? G. G as well as K value. Okay. Here is the average means mean G, mean K. Okay. Next, the calculation part is there. This is the calculation. From this we got the answer. The formula is K, figure of merit. Okay. That already given in a tabular column, and also G formula is also given in tabular column, and like that they simplified here. Okay. Here simplification of K. E means 2.5 divided by R plus G into theta 10. Okay. After simplifying, we will get 0.40146 ohm. Okay. This is second reading, and this is third reading. Okay. Here you may also express the K value in terms of 10 power minus 6. Here this one third reading becomes 14.6. 14.6 into 10 power. I am moving the digit, that is 1, 2, 3, 4, 5, 6. Okay. That becomes 10 raised to minus 6. Okay. K value means why? Because the galvanometer range is there 10 micro ampere per division, and also 20 micro ampere per division. Like that the range is there. Okay. Next one is result. Okay. This one is the result. Here you have to mention the mean value K, mean value, mean of G, that becomes 46.86 ohm. Okay. And figure of merit of the galvanometer, that is 14.6 into 10 raised to minus 6 ampere per division. Means the given galvanometer is near to, means that you have the range of 10 into 10 raised to minus 6 ampere per division. Why? Because the 14.6 is the nearer to 10. Okay, that's why the given gamut is of this range. If the our mean value near to 18 point or 19 point, then the given galvanometer is of the range of 20 microampere per division. Okay, thank you.